you're a musician and you're in the studio jamming out, right? And you want to do some mathematical analysis of the music that you're jamming out with, because you're a math nerd, just like me, right? And you analyze a note that you've played, and it looks like this.
How do you do that?
Ooh,
How'd you get
right?
that?
I made it up. Bam. No. Let's say the music note that you analyzed is that gives you that function.
How would that be stupid?
Okay. There are a couple questions we can ask.
How did you get there? Yeah.
Why do we have to do this?
Can you reverse
you're a
the
math
steps and
nerd
write
and you-
what?
Why did somebody
Okay.
come up? Too bad I'm not a math nerd and I don't do
What are some good
Can we just stop them?
questions that you could think? I say
What
good.
note is this?
Oh, okay. What note is it?
Well, I stole your.
How do you decide about it?
What else?
How fast does a bullet?
Okay, that's not based on this. We're going to focus, Brandon.
What's the
Thank you for being
amplitude
here.
of that? No.
That's a fantastic question.
See, I'm smart.
In music terms, what's the word?
Amplitude.
Brooke, can you stop, please? It's like this murmur in my ear.
Pitch.
Amplitude is also called
Pitch. Volume.
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 How loud it is.
If it's too loud, you're too old. Right?
What? No, it's not loud enough. It's cool.
Okay. So that would be an answer to the question of what is that number?
Volume.
Okay?
Wait, that's the answer? The amplitude is 21?
Yeah. So what
Easy.
what else is there that you could ask questions about?
What's the frequency?
Okay, frequency.
That's what I said.
Wait a second.
Or in music terms?
Pitch.
It's pitch, yeah.
Pitch and yaw.
That would be a boating term, but there you go. Okay, so those three questions we can answer today.
No way.
Doesn't different, like, okay, so there's several B flats on the piano, right?
Different octaves.
Different octaves.
Yes.
So where would pitch come from if they're all different?
The pitch of a note with different octaves. So if you have a, let's say a middle C, right, on the piano, the next octave up, the pitch will double.
Double.
Then the next octave up will double.
So
Down.
do we
Down it
have
will
to
half.
figure out where on the piano the thing in our song is for the project?
Please don't.
No, you can do it all numerically. Yep. So when we get to pitch, when we calculate what pitch frequency this function is and what note,
It's just
we
whatever.
can then move an octave up or down just by doubling or halving the pitch. Right? Okay. So that right there, we can graph.
Oh, no. That's
I'm going to section this off. So first we're going to address amplitude. Okay? Sound good?
yes, sir.
We're just going to worry about this. So for now, I am just going to work with this function. Okay, that right there is the amplitude. Or volume. Okay, obviously volume has to be coded in according to the manufacturer of the hardware, right?
Yeah.
You notice some companies go from -50 to 0, or some companies go from 10 to 50 on their volume settings, like it's all different. So this would be completely determined by them, obviously, whatever hardware you're using, right?
Do we just say high and low? High volume.
How do you get negative volume?
How do you get negative volume?
Negative number.
They're basically using 0 as their maximum, and everything below that is below the maximum. So you're 50 below the maximum, or -50, right? That's just it's up to the company that builds the hardware. It's not really matter to us. Okay, Sine x. What is the amplitude of y equals sine x? was 1, right?
Yes, sir.
And we went from 1 to negative 1? Okay, well here we're going to go from 21 to negative 21. That's the difference. Okay, it just changes the height of the wave. And I'll scale this so it's friendly. Okay, 20 to negative 20. And then, again, our standard sine, cosine graphing sections there. Pi over 2 pi, 3 pi over 2 pi, just like it's on your sticky note. Hopefully it's on your desk, right?
What's that? 3 pi over 2?
Yeah. But basically, again, it's 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. This should be 2 pi. Good job there. Okay. And then it's the same pattern as sin x. You just have to go up to 21. All right, so we're going to start here, but our next point's going to be at 21. Then we're going to go back to 0, and then we're down negative 21. All right, so there's your 21 sin x. And now you're bumping and thumping with your 12-inch subs. Okay, you all right with that? It's really easy. Like, okay. Let's talk about the rest of it. What was 784?
It was a dial and a button to control the screen. Down next to it. And the screen was up here.
Oh, that's dumb. Okay.
I'm pretty sure
What is X?
I'm pretty sure I have those.
X is your time variable,
Oh.
right? Personal preference here. If I were writing these equations, I would not put X.
You put T.
I would make it.
Yeah.
Okay, I would put a T in there just because that's time, right? It doesn't matter. It's a variable. Okay, so this is personally what I would do. I think your book does both, right? So just be able to work with the variable in that respect. Okay, so if you are looking at this from the lens of music, which we are, this is the format that you're going to be working with, and I've shown it to you once. B is the frequency or pitch in music. So those are the same thing, right? They're the same thing. Just different content areas use different names. Physics versus music. Kellen.
So that's the volume.
Okay, this one is 1.
Oh.
Right, we're just looking at this right here. Okay. So what is the value of B in our?
Half of 784.
Yeah, half of 784, right? So B equals 392.
Yeah, correct.
Yeah, because 392 times 2 is 784.
Yes, sir.
And that is, in music terms, cycles per second, hertz. Okay.
Is that what hertz is?
Yeah.
I thought that was to measure volume.
No.
Oh. So remember, one cycle is one.
How many notes passes 20 seconds?
One cycle is one period, right? That's the other word for it. So 392 of those per second.
Dang, that's fast in the middle note.
Actually, it's not.
Oh,
Believe it
that's
or not.
I lied.
Puts
Okay.
you in your place.
And then, based on what we know, does anybody have that memorized?
What?
392 hertz is what note?
That's a B flat.
It's not a B flat.
That's F sharp.
Why are you stuck on B flat?
It's an F sharp.
That's, I don't know.
It's
Is that an
It's
F
C
sharp?
minor.
it's the G.
Oh.
It's a G
Flat.
The G sharp.
sharp.
So on again on the
G
piano
sharp.
you have middle C. It's the G that's just above that. So G, you have C, C sharp, D, D sharp, F, G.
Lost me at D sharp.
It's right there.
H-I-G.
Right, so
I thought it does say HIV.
Yeah,
so
it's going on
you are working backwards here, right, to build your formulas.
Yeah.
So you'll identify your note. You'll go find the frequency, which I showed you how to do Friday, and you'll build your equation. Okay?
Please.
I moved it.
Keep going.
All right. So that's kind of the process you'll follow. How are you going to graph that?
You plug in the calculator. You just graph that. You say y equals sine
Okay.
times 2 pi times x.
Here's how you graph it.
Like that one now.
You go to Wolfram Alpha and you type in the equation and it does it for you.
What? But that's G9.
That's
Here's how
awesome.
you do it by hand.
You can't do that on
Okay.
G9.
The period of a function, there's a couple ways to do it, is 1 over frequency, if you know what frequency that you're operating at, which we do, right? Okay, this is where we're at right now. This is the easiest way to do it. The period is the length of the wave, right? So if I were to graph a sine wave, the period
It's right at the end.
is the size, is the wavelength.
One wavelength? or the
Yeah,
whole thing?
one wavelength. So that tells us the x value is 0 to whatever. So if I can figure out the period, 0 to this gives me one cycle. Okay? Good? Right, so our period is 1 over what?
392.
392. Is that a really small number?
Yes.
Yeah.
Yeah, it is. Yeah.
That's small.
It's like almost.
So does the smaller frequency, the faster wave?
Yeah.
Yeah, the,
So what if your frequency was 1?
then the period would be 1,
And what does that mean?
and we wouldn't be able to hear it. That means one wavelength, one period would pass per second. Okay. Now, considering the speed of sound, 300 feet per second, that's a long sound wave, right?
A radio
300
wave.
feet long.
Oh, I already told that.
All right, so the period's 1 over 392, right?
Yeah.
So literally, your wave is only 1/392 of a second.
So you can
hear
that.
Barely.
Not even. Yeah. But 1/400th. Okay. And then, what's our amplitude with this function?
So it's 1.
Yeah, in our case, it's 1.
That's a
Negative
long
1.
wavelength.
I should put this out one more to make it. But it's the same pattern right there.
Wow.
Okay. We're not using, obviously it's not 0 to 2 pi because we've changed the wavelength. At standard sine x wavelength is 2 pi. Here we're in a specific situation where that changes.
So it's always at 1 though, if you're just doing
Okay.
the frequency. Or, yeah. Right?
What?
If you're graphing, No, if you yeah, it's always 1. If you're graphing frequency, it's always either 1 or negative 1.
No.
Oh, only,
Only if you're graphing B.
okay.
No,
Just
only if your amplitude.
Keep in mind, my amplitude here is 1,
If your amplitude is 17.
right?
So
That's
that
why I
was
went
like-
from 1 to negative 1.
So if that was like 22, it would be a
Now, I could change both factors, right? And I could stretch it both ways? Yeah, okay, good.
yeah.
Okay. All right, so that's one way. This is more musically oriented graphing, right? Okay. Here's the way that a mathematician would probably explain it to you.
No, I need to do that first with a pre-calc. No. Dan.
This is the value that we would call, your book calls it K. Just some arbitrary letter that can change. The period is 2 pi over K.
Why do they have to make it?
It's not hard.
It's just harder than that, though.
No, it's not.
It's the same thing.
You've just done that. We've done in 2 steps.
Right.
So, it's the same thing. 2 pi, see, right? 2 pi times 392. And then 1 over frequency gives us 1 over 392.
Yeah.
That's 2 steps. This formula that I'm showing you now is a 1 step.
1 is the 1.
Yeah, so 2 pi
Oh, it's just 1/2.
over 784 pi in this case, right?
Yeah, that's just 1/2 of that. 392.
The pi's cancel out, 1 over 392. It's the same problem. You're just approaching it from more of a mathematical physicist feel, more of a musician
I'll
feel.
just put, if
Okay.
you want to feel smart. But if you're just, no one can be-
You get one lucky.
Good stuff right there. Okay. All right, so let me give you a pretty standard math type of problem where we have a period that involves pi and we'll be good. Okay. Good? Good, good. Graph, let's see, graph. I'm just gonna take one.
That's cheating.
You're not cheating, you're not trying.
Thanks, Mr. Johnson. Okay, so y equals 1/2 sine 4 theta.
What's a theta?
Theta is a Greek letter, it's a variable.
Theta, I remember theta.
So again, if I want to, I can write this 1/2 sine, 1/2 I have a stutter, 4x, same thing, right? Okay, what's the amplitude?
The amplitude, my friend, is
Half.
1/2.
What's the period?
1 over 1/4. 1 over 2.
This is, yeah, this is the k value, right?
Yeah.
Right, so the period is 2 pi over 4. Okay. K value, 2 pi over k.
Pi over 2.
The period is pi over 2.
90 degrees.
I don't know why I want to blow up on somebody right now, but I do, just for fun.
Shut up.
Take a chill pill, man.
I looked at it.
Okay, so if we're going to graph this, you're okay calculating that? Yes?
Yeah.
It's just a formula, algorithm.
Yeah, it's not much.
Sure.
What's my amplitude?
1/2.
Yeah, 1/2 to negative 1/2, right? And then if I'm going to pi over 2,
There you go.
what's in the middle?
Pi.
3 pi over 2.
3 pi over 2,
What's-
pi and pi.
What's half of pi over 2?
Oh, no.
Pi over 4.
Okay, you're not on 2 pi anymore. Okay, 2 pi is way out here, right?
Oh.
So 1/2, then we would have pi, 3 pi over 2. That's way out there. We've just shrunk this wave from that big. Now it's going to repeat here.
Like the opposite.
Okay,
So would it be
So,
3 pi over
your sine wave still looks the same, but it repeats in pi over 2
I'm guessing that's a lot
units.
higher frequency.
It's a higher frequency, yeah.
So it's like
4 times as higher than the normal sine curve, actually. How many times does this sine repeat?
like
4.
4.
In this interval, this function would repeat 4 times, right? Where our standard sine would only repeat once. So this is 4 times,
Oh, that makes so much sense now.
right?
Oh,
There are 4 sine curves in the same interval,
Interval. Define interval.
0 to 2 pi is an
but it's
interval.
not as loud as the other one.
So the regular sine curve would repeat once, sine 4 theta would repeat 4 times.
It's just not as loud though, right?
Okay? Kellen,
So just to make sure I have the pattern right, right before pi over 2 would be 3 pi over 2?
pi over 4,
Pi over 3 is right there. Pi over
okay. No, this is going to be pi over 8 and 3 pi over 8.
3 pi over 8. How do you figure that out?
So when you have fractions, you always want to get that common denominator. So I halved it, I didn't see a common. I halved it again. Pi over 4 halved is pi over 8. That's going to give me the denominator I need. So pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8.
Wow.
And then you simplify.
So,
But obviously all you have to work with at the beginning is pi over 2.
so on the circle, would before pi over 2 be going this way? You know what I mean? Like the unit circle? Yeah.
Pi over 2 is 90 degrees.
Yeah.
Pi over 4 is 45.
Oh, right.
These are not on the unit circle.
Really?
Nope.
That's bizarre.
It's not bizarre. The unit circle is divided into 12ths, not 8ths.
Oh,
Okay.
weird.
Are you good? You think you can handle graphing sine and cosine
Sure.
with different amplitudes, period?
Possibility.
Okay.
It depends on how hard the problem is. Darn. Is this due Thursday? Since we have 6.3 due tomorrow?
16 and 58 are music problems. Okay, good practice for your project type stuff. Yep, have at it. Let's see what we got here. Let's see, tomorrow 6.3 is due.
Yeah.
Okay, let's make this due on Thursday then. Just to spare you, because a lot of you have basketball games
Yeah.
tonight. Wrestling practice. Violin practice. Some of you have pre-calculus homework that you need to make up. I say that out loud?
Yeah.
Bummer. Okay. I will pick those up.